people are doing well? Fine. Today we are going to do the work based on laws of powers. You have already learned in 7th, 8th and 9th. 7th, 8th, alright, not 9th. You learned 9. So we are going to use once again laws of powers. There are 5 laws. Multiplication of powers, that is first one. Second, division of powers. Third, power of power. Fourth, power of product. And fifth, power of quotient. In the last 3, there are single power. Power, power, power. And here, multiplication of powers. Multiplication of powers. So more than one powers. So whenever you have to deal with more than one powers, you are going to apply first 2 laws. And if you have to deal with single power, you are going to use this last 3 laws. Let's see what is the law. Suppose this is x raised to a. That is one power whose base is x and the index is a. There is another power with like base. Base have to be like. Raised to b. So 2 powers, x raised to a, x raised to b. What we are going to do? Multiplication. So according to multiplication of powers, what is the law? Common base x and the indices are added, a plus b. Can you recall this? Yes, this is called law of multiplication of powers. When you have more than 2 powers, 2 or more than 2 powers with same base, this base should be same, then only you can apply this law. So that common base is x. If it is multiplication, you have to add the indices. Let's see now. X raised to a, x raised to b. Powers more than 1 power, plural. एक से ज़्यादा powers है. But this time it is division. According to the law, the common base is x and you have to subtract the exponents, indices, a minus b. Is that clear to you? Fine. The next one. X raised to a. That is the power. Now this, what is the base of this power? X, an exponent a. But I am taking this in the bracket and making it base, raised to b. So this is another power. The red part that you see is 1 power. And red is taken as base, an exponent b. That's another power. So we call it power of power. According to the law, the base x, the base of the inner power, जो ब्रैकेट के अंदर पावर है उसका बेस, and inner exponent and outer exponents are multiplied, a multiplied by b. This is the law of power. According to the law of power, the base of inner power is taken base, inner exponent and outer exponent are multiplied. Okay. Power of product. Chaliye. This is x into y. This is x into y. So what you are having? Product. This is product of x and y. That is base raised to a. Single power whose base is x into y and index is a. Power of product. And according to the law, nth power of x, that is x raised to a, into nth power of y, that is y raised to a. This is the law of power of product. Similarly, we have division. Yeah, when you divide, you get quotient. X divided by y, you get some quotient. Raised to, let's say, m instead of a. So here, according to the law of power of quotient, x raised to m upon y raised to m. That is the law. Mth power of x upon mth power of y. Both are divided. Yeah, both are multiplied. 8th power of x into 8th power of y. Let us use these laws now. Okay. The question is simplified. Question is simplify. All right. First, 2 raised to 2/3 into 2 raised to 1/3. Now, very interesting, children. If you have not done well in the lower classes, please pay attention. You will get it. It's very easy. First, see, when you have more than 2 powers, like a plural means 2 or more, and a single power, singular, correct? So if you have more plural number of powers, more than 1 power, you are going to use first 2 laws. And if you have single power, you are going to use last 3 laws. Whatever is applicable, you use. Okay? Check. So look, what you will use? First 2, from first 2 or from last 3. So see, is the power single or plural? Singular or plural? Plural. दो power है. You can see power with base 2 and there is another power with base 2. And how are these powers? What is the operation performed? You can say multiplication. If you want to use the law of multiplication of powers, the bases have to be same. So they are same too. So write that. And according to the law, exponents, indices have to be added. 2/3 plus 1/3. बड़े प्रेम से उसका सिंप्लीफिकेशन साइड पे करो रफत में. 2/3 plus 1/3. Oh, we are lucky, like denominator. So whole upon 3. Up you may write 2 plus 1. What is 2 plus 1? 3 upon 3. And what is 3 upon 3? 1. So that is equal to 2 raised to. What is the simplification of this? 1. And 2 raised to 1 is 2. So that is the simplification. Is that clear to you? So let's see the second example. It is 3 raised to 1/5 whole raised to 4. Can you identify, children, whether we have 1 power or more than 1 power? How many powers we have? Only 1. In the bracket there is 1 power, but you can say that is base and the index is 4. So only 1 power. Lekin index 4 and that base is again a power. So this is power of power. Third one is applicable here, right? So according to the law, the base of the inner power, that is 3. Now this is inner exponent and outer exponent. Bracket के अंदर का exponent, bracket के बाहर का exponent. Those two we will have to multiply. 1/5 multiplied by multiplied by 4. बड़े प्रेम से multiply करो. कुछ cancel होता है तो करो, कुछ भी नहीं होता है. 1 4s are 4 or 5. So that is 3 raised to. What is the exponent? 4/5. बस उसके आगे कुछ नहीं होगा. You cannot simplify this further. This is simplified. That is the answer. Is that clear to you? Good. Now, next one, number 3. 7 raised to 1/5 upon 7 raised to 1/3. What do you say? 1 power or more than 1 power? No, you cannot say this is more than 1 power. Whole raised to something nahi hai, bracket nahi hai. So you can say 1 power exists as numerator and 1 power exists as denominator. 7 raised to 1/5 upon 7 raised to 1/3. Upon means division. So you have 2 powers. ये इसमें से 2 में से कोई law use करना पड़ेगा. And which one is that? Division of powers. If you want, you can write in that form 7 raised to 1/5 whole upon. You can put division sign 7 raised to 1/3. If you want to apply any of these 2 laws, base have to be same. Yes, base तो 7 7 है. So let's write 7. And according to the law of division of powers, those exponents have to be subtracted. So first exponent is 1/5 minus 1/3. बड़े प्रेम से इसको subtract करो साइड पे, पिछले पेज पे नहीं, not on the last page, same here इसके बाजू में. 1 upon pi minus 1 upon 3. Children, this time they are not like denominators. So we'll have to make extra efforts to simplify this. Yeah. Can you tell me what is LCM of 5 and 3? Simple. 15. Correct. Now, say 5 ones are table till you get 15. 5 ones are 5, 5 twos are 10, 5 threes are. 5 threes are is 15. So I am writing 3 in the bracket. Can you say 3 ones are table till you get 15? 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15. So I will write 5. Alright, this is 5. Now, these are to be multiplied. Bracket में जो है 3 into numerator, 3 ones are 3 minus 5 ones are 5. So that is equal to, oh, this is 3 minus 5. That is 2 और बड़ा number 5 with minus sign upon 50. So that is equal to 7 is the base. And what is the simplification of this blue part? Minus 2 upon 50. Oh children, here the index is negative. Again there is a rule. You can write 1 whole upon the whole power 7 raised to 2 upon 15. ये minus हो गया plus. When you take it inverse, उसका inverse कर लेते. So that is the answer. Is that clear? So what is the simplification here? 1 upon 7 raised to 2 upon 50. That is the simplification. Alright. Next one. Let's see. सिर्फ simplification करना है children. We have to just simplify. Fourth one. 13 raised to 1/7 into 17 raised to 1/7. Okay. Identify करो. Is it singular? मतलब एक ही power या more than one power plural? Obviously, एक power है, एक power, more than one power. And the law is multiplication. So we will be using multiplication of power. But please, देखो, you can use this too only if the bases are like. Here base is 13 and here base is 17. Same base नहीं है, like base नहीं है. So you can't use that law. तो क्या करें? तो एक चीज ऑब्जर्व करो. You have common index. दोनों का index common है. Both of them have the same index. So you are going to ये multiplication. You are going to use this, but not power of product. उसका उल्टा. देखो, x raised to a into y raised to a. So दोनों का index same. So you can put in the bracket x into y, or common index you can put out of the bracket. Same thing I am going to do here. Bracket में product of the base is 13 into 17. और ये just one time common. जो common है वो one time. So we use this law, but not directly converse. But now you multiply. What is 13 into 17? 0, 3, 1, 21, 9, 1, 2, 2. So this is 221 raised to 1 upon 7. After that you can't do anything. Okay. So this is the simplification. Got it, children? Sure? Fine. Alright students, so we move to the last concept of the chapter, and that is once again representing irrational number on the number line. We have already represented root 2, root 3, root 5, root 6, root 7, even root 11, root 13, root 17, any number which is non-perfect square, correct, can be represented on the number line. Now there is slight twist in the question. Root 4.2. 4.2 isn't perfect square. So square root of 4.2 is irrational. Root 9.3 or square root of 5.8. So this type of numbers which are non-perfect square and its square root are irrational. We have to represent this irrational number on the number line. Children, how we get it on the number line? That is a difficult concept. But to obtain this square root, I mean this irrational number on the number line, is easier compared to the lengthy method of plotting this irrational number on the number line. ये irrational number को number line पे प्लॉट करने के लिए बहुत लंबी मेथड है, बहुत कुछ करना पड़ता है, यहाँ कुछ कम करना पड़ता है, लेकिन the concept of how we are getting that is difficult. So first we'll have to understand the concept, and for that we make few pre-preparations. Let's recall certain knowledge that we already learned earlier, okay, or we possessed earlier, we acquainted earlier. So few things that we are going to see before we plot this type of irrational number on the number line. The first thing that we should understand is, number one, betweenness. Betweenness, very easy concept. All right, look here. This is a number line. This point is A, this point is B, and here is point C. Alright, so we can say B is a point between A and C. That's why this concept is called betweenness. Very simple, isn't it? Acha, suppose AB is 5 units. The distance between 2 points AB is 5 units. And the distance between BC is 7 units. Can you guess what is the distance between A and C? Correct. 5 plus 7. So AC is going to be 12 units. Correct? So what is the result of betweenness? इसको symbolically ऐसे लिखते हैं, A dash, B dash, C, which means B is between A and C on the same line. Second, AB plus this distance between A and B, that is AB, plus distance between B and C, that is BC, is equal to distance between A and C, AC. 5 plus 7 is equal to 12. Did you understand? Are you getting me? Say suppose you got Q dash P dash R. So what you can say? PQ plus PR is equal to QR. Say suppose you have M dash O dash N. So MO या OM plus ON is equal to MN. Did you understand? It is very simple question. Alright. Now, I'll have a little twist here. Okay. Suppose AB is X. That is distance between point A and B is X. And distance between point B and C is Y. So what will be the distance between point A and C? What will be AC? You know it is AB plus BC. So what is AB? X. Plus what is BC? Y. So what is AC? X plus Y. Is that clear to you? Alright. Now considering the same concept. Suppose AB is X and AC is Z. AC is Z. Then what is BC? Can you guess? Yes, quite easy. Directly you can say the whole distance AC minus the distance AB. So Z minus X. But technically how you get that? See this, A dash, B dash, C. So you can say AB plus BC is equal to AC. Now AB is known, AC is known. So put their values. What is AB? Therefore X. BC we do not know. That is what we have to find. So BC is equal to, what is AC? Z. So make BC subject to the formula because we want to know what is BC. So BC is equal to Z. X goes on other side minus X. So this BC is Z minus X. Did you understand? Sure. All right. So ये एक concept था betweenness का, which you had to understand. All right. Now Second concept, that is distance formula. It is about distance formula. I have already discussed in video 7, but one girl sent me message. She did not understand anything in video 7. Alright, I said in the last video I will repeat few things. So here I am repeating one thing. It's very easy. Alright, now since I am talking about distance formula separately and I am going to explain it separately, you will understand and you will see how easy it is. Alright, once again, the number line. This is number line. Alright, this is okay. Here is 0, 1, minus 1, minus 2, minus 3, 1, 2, 3, 4. Alright. Let's say this point is A, this is B, this is C, this is P, this one is Q, this one is X, this one is R, and this one is M. Different points. Alright. Now there is one distance formula. Suppose you want to find distance between A and B. So AB is equal to absolute value of number corresponding to point A. Which number corresponds to point A? Let's say small a, not minus 3 just now. The capital A is point and the real number corresponding to that point is A, minus real number corresponding to point B, let's say B. So this is called distance formula. This is distance formula. Suppose you want to find distance between Q and R. So QR is equal to absolute value of Q minus R, where Q is a real number corresponding to point Q and R is a real number corresponding to point R. Now what does this absolute value or modulus value says? If you want to remove modulus value, okay, fine. Here, this is small a, number corresponding to A, and this is small b, number corresponding to B. Which is bigger number? If you look at the number line, B is to the right, so B is bigger. So B minus A, absolute value, your modulus of A minus B is bigger value minus smaller value. So bigger value minus smaller value. So answer would be always positive. That's it, same here. Let's talk about Q. So this is a small q and R. This is small r. So what is the distance between small point Q and R? Absolute value of Q and R. Which is bigger, Q or R? Look at the number line. Oh, this is R, I'm sorry. Which is bigger, Q or R? R is located on the right, so that is bigger. R minus Q. R minus Q. So that is positive. ये absolute value निकाल दिया. Big minus small. Whenever you remove this absolute value, your modulus, you have to write big number minus small number. The real number which is big minus real number which is small. So that ultimately the answer is positive. So that's how you can find out. Okay. Now see, let's find out few distances here. Suppose you want to find distance between point B and point M. So you will say BM. Correct? The distance between 2 points is BM. So that is absolute value of B, that is small b, minus small m. Okay. Now look at the figure. B is on the left and M is on the right. So which is bigger? Small m, real number, and this is small b. Alright. So out of small b and M is bigger. So I write M, bigger number, minus smaller number. Now what is M? 3. Correct? Minus. What is B? Minus 1. So that is 3 plus 1. And that is 4 units. So what is the distance between B and M? 4 units. You can see on the number line and verify. BM. This is 1 unit. This is 2 unit. This is 3 unit. And this is 4 units. So distance is 4 units. Let's take one more example. AP. AP. So you can say absolute value of A minus small p. Small a minus small p. Now look at the figure. A is on the left to the number line. P is on the right to the number line. The point, the real number corresponding to point on the right is always bigger. So I will say small p is bigger minus small a. So absolute value is gone. I mean the modulus is gone. These two vertical lines are gone. Big number minus small number. Now what is P? 4. So 4 minus. What is A? Minus 3. So write in the bracket minus 3. 4 plus 3, and that is 7 units. So what is the distance between point A and P? 7 units. Let's verify. A is here and P is here. Now this is A to Q 1 unit, 2 unit, 3 unit, 4 unit, 5 unit, 6 unit and 7 units. Can you see? So ये distance की बात आपको पता होना चाहिए. Alright, still distance formula based ही एक question देखते हैं. Let's see a question based on distance formula. Let's see these 3 lines. Okay, they are number lines. Point A is here and number corresponding to it is 5. Point B is here and the number corresponding to it is 15. Point Q is here, number corresponding to it is minus 4.2. Point P is here, the number corresponding to it is 2.8. Point is here, the number corresponding to it is 3 by 2. Point here, the number corresponding to it is 23 by 2. Okay. Now you want to find the distance AB. Okay, I'll write here distance AB. So that is absolute value of A minus B. इसको कहते हैं absolute value या modulus value. When I put two vertical segments. Okay. Now which is to the right? Point A is to the right or point B is to the right on the number line? B. So small b is bigger. So small b big minus small a small, right? Okay. So what is b? Arey bhai, real number corresponding to b 15 minus real number corresponding to a 5. 15 minus 5 10 units. So what is the distance between these 2 points? 10 units. Let's find out the distance between these 2 points. Let me say PQ instead of QP. By PQ kaho ya QP kaho, the distance between the 2 points would be same. So this is absolute value, yeah, modulus value of small p minus small q. Now tell me which point is to the right? P. So number corresponding to p is bigger. So small p is bigger minus small q. Modulus gaya. Now p corresponds to 2.8, correct? Minus q corresponds to minus 4.2. So 2.8 plus 4.2. If you add, you are going to get 7.0. So what is the distance between these 2 points P and Q? 7 units. Let's see this. Suppose this point is M and this point is N. Then what is Mn according to distance formula? Small m minus small n. कौन सा small m big है कि small n big है? N is to the right, so small n is big minus m. Now what is big? 20. What is that n? Small n 23 upon 2. Minus what is m? 7 upon 2. Like denominator, so 23 minus 7, and that is how much? 16 upon 2. 2 ones are 2 8s are. So 8. So what is the distance between these 2 points? 8 units. Are you getting me? Sure? Understood? So that is about the distance formula. All right. Now, next concept. Children. Third, it is about midpoint. It is about midpoint. Suppose this is a number line. Here is A and here is B. The distance is given. Distance between these 2 points is 8 units. What is the distance between these 2 points? 8 units. If I take a point mid of AB, exactly in the middle, आपको याद है ना? Then AM equal to MB. AM is equal to MB and that is equal to half of AB. ये पूरा 8 units है, तो ये 4 units होगा और ये भी 4 units होगा. Then only you can say M is the midpoint. So if M is midpoint of segment AB, then you can say AM is equal to MB is equal to पूरा AB का आधा, half of AB. So this is midpoint result. Please remember. Okay? Clear? Alright. Next concept is of construction, and that is perpendicular bisector of a line segment. Fourth concept we need to know, perpendicular bisector of line segment. Alright, here एक number line लिया, I am taking 2 points A and B. You want perpendicular bisector of this line segment. Just imagine line segment, that is a part between A and B. I want perpendicular bisector. Have you learned that construction, how to draw perpendicular bisector? उसके लिए आपको क्या करना है? Take A, the one end point of line segment AB, and draw circle with center A and radius half of AB. Middle point यहाँ आएगा, उससे ज्यादा radius ले लो. So here and here. Above the line you draw one arc of the circle and below. Then take point B as the center, the other end point, and draw that circle. My God, I missed. So I'll have to draw this again. Alright. Now this point of intersection, let's say this point is P, this point is Q. Draw a line passing through these 2 points P and Q. I won't draw bold line, I'm just drawing a dotted line. So this dotted line, let's say line L, passes through the midpoint. ये जो point है, that is always a midpoint. That's why this red line L is called perpendicular bisector of line segment AB. We have considered only the endpoints, line segment AB. So this is how you draw perpendicular bisector of line segment AB. I'll just repeat. Line segment AB has 2 endpoints. One endpoint is A. So take that center and appropriate radius. Radius half of AB से ज़्यादा होना चाहिए. So you have drawn 2 arcs, one in upper half plane, other in second half plane. Then you are drawing another circle. This time we are changing the center. Radius is same. So center B, you are taking center B and radius same. So the second circle will intersect the first circle in 2 distinct points P and Q. Then draw a line through these 2 points. This line is always a perpendicular bisector of line segment E. And the fifth concept that we need to know is Pythagoras principle, that we already know. We need to know is Pythagoras principle. I'll take one example of Pythagoras principle, okay? Well, this is one side. This is other side. This is a right angle. And this is the third side. Alright. So we have 3 sides. Red, black and blue. What is the blue one called? Correct. Hypotenuse. It is called hypotenuse. And if you call this one as base, then this is the altitude. This is the altitude. Children, see what I am saying. Suppose length of this base is 1 unit. The length is 1 unit. And length of this is A plus 1 by 2 units, where A is any real number unknown. It is difficult, no? A, B, C. Triangle ABC is right angled at B. AC hypotenuse, the length is A plus 1 by 2. BC base, it is 1 unit. Then how much will be the altitude? Altitude kitna hoga? Let's see. By Pythagoras principle. Boliye, which is the hypotenuse? AC. AC square is equal to sum of the squares of the remaining two sides. AB square plus BC square. What we want is altitude, and altitude is BC. BC is the altitude. The next two are known. What is AC? Oh, A plus 1 by 2 whole square. That is equal to AB, that is 1 unit. So 1 square plus BC square. Okay, this is A plus 1 whole square. Square of numerator upon square of denominator. Earlier in this session we saw power of quotient. What is square of 2? 4. ये square of 1 ये बाजू लेके आए -1 हो गया. That is equal to BC square. 1 upon 1 you can take. Alright. I'll erase this part and continue up. Therefore, बोलिए. Oh children, this is square of binomial. First term square, A square plus 2 into first term A into second term 1 plus second term square, that is 1 square, whole upon 4 minus 1 upon 1, that is BC square. Chaliye, this is A square plus 2A plus 1 whole upon 4 minus 1 upon 1, that is BC square. Alright, let's continue further. Therefore, children, what is LCM of 4 and 1? 4, correct? Chaliye. 4 ones are and 1 fours are. So this 1 has to be multiplied with this trinomial. 1 into trinomial would be same trinomial and no need of bracket. A square plus 2A plus 1 minus 4. 4 ones are 4. That is equal to BC square. Alright. Proceed further. क्या आता है देखते हैं. Now this is therefore A square plus 2A plus 1 minus 4 is minus 3 upon 4. That is equal to BC square. Finished. I.e. BC square is equal to A square plus 2A minus 3 upon 4. I.e. BC square is equal to square I am removing, taking square root on both sides. Square root gone. That is A square plus 2A minus 3 upon 4. 4 in the denominator is perfect square. So you can say root A square plus 2A minus 3 upon 2. This is BC. The altitude BC is square root of A square plus 2A minus 3 upon 2. Do you understand?